Okay, welcome to the next video here. I think in this one, we really want to start figuring out how the computer picks an option. We already are capturing, what we pick, right? We pick an option by hitting either rock, paper, scissors or RPS on the keyboard. So that part's pretty easy, and we're already checking in our JavaScript if that behavior is taking place right here. So we already have some logic already set up, which is good. We kind of set that up very early on. The thing that we don't have, again, is the computer choice and how we kind of capture that. So I think what we want to do is really jump into that code. So let's do that. So I think what we want to do is really the computer shouldn't be picking a guess until we pick a guess. So like if I press the A key, the computer doesn't need to make a new choice. It only needs to make a new choice when I make a choice. So I think what I want to do is I want to have a function. We're going to make another new function, and I'm just going to call this one, I don't know, like computer picker or something. So let's make another doc block for us here. So this function is going to do a lot. It will pick a guess for the computer from the available options. It is going to, well, I guess the options that it can pick from are going to be set in an array as R, P, or S for rock, paper, or scissors. We're going to use a couple things here. We're going to use a method called, or we will call math.random, which is going to pick a number for us between 0 and 1. That math.random thing, the special part about that is it is inclusive of 0, but not of 1. Meaning when it makes a random number, and I'll demonstrate this in a minute once we get into the code, but it can generate a 0, but it cannot generate a 1. The highest it can go is 0.999999, however many numbers go in there. That'll make more sense in a minute. Once we get that random number, we're going to call another method called, or another function, math.floor, on that random number, on the response from math.random, and that which will give us it's going to give us a whole number basically. We'll demonstrate that more in a minute. Actually, I think that's probably good comment-wise. I think it's probably better to just start writing some code here. We'll probably change that more in a minute. So let's make that function. Again, that function we're going to call computer picker. So computer picker is going to pick the computer's option for us. So what I want to do is the computer, I'm going to give it a list of options that it's available to pick from. I'm going to put that in an array. So I'm going to have R, I'm going to have P, and I'm going to have S. Those are the options that it can pick from. So this is a collection of options. So an array is a great use case for something like this. So I will store that value in an array, and I will save it as a variable. So I'll call it var computer options equals that array. So these are the only things that it can pick from, and maybe down the road, maybe there's a new option, right? And I could just add that in. Maybe I want to say, I don't know, T. I don't know what the hell T would be, but if I want to change the rules of the game, I can kind of easily do that by giving it a new option in this array. But we're playing rock, paper, scissors, so we'll give it its 3 options. So what we're going to do is have a random number be generated. And that random number will give us a random index in our array. So if we get the number 0 as a random number, it will equal the letter R. If we get the number 1, it will equal the letter P. And if we get the number 2, it'll equal the letter S. And that's true because the 0 index in this computer options array is R, the 1 index is P, and the 2 index is S. So that's kind of why we're doing that. And the way we do that is we'll kind of demonstrate this and build it out. So we'll do that by saying we have a new variable called computer choice. And we're going to say that's equal to math.random. So, and then we're just going to console log it. Computer choice. And we're just going to, just for right now, we're going to call this function down here just to demonstrate what's actually happening here. So I have a function. That function in there has an array. The function isn't calling the array, it's going to use it, but it has this array of options. It's going to generate a random number using this math.random, using this random method off this math object. This is something that we'll dig into at a later time of what's actually happening and where we're getting this math thing from. But for right now, this is something that's given to you. It's nothing that you have to create. It's something that's just available for you. We're going to use a couple of these methods. So it's going to do something here. We're going to, whatever it does, we're going to save here. And then we're going to log it. And actually, now that I think about this, instead of calling it just on load, get rid of this. Let's put it on our button because I'm going to call it a whole bunch of times. So every time we click our button, let's call this function and see what happens. So I save this. I'm going to go back to Chrome. I'm going to refresh this. I'm going to go here. Oops, I don't know what the hell I put down. I'm going to open up the console and I'm going to hit the reset score button. Let me clear this. So you can see every time I hit this button, I'm getting a new number in the console, right? So these numbers are somewhere between 0 flat to 0.99999. So you can see they're always going to start with 0, but the numbers after the decimal point are going to change, and they're relatively long, pretty random. So that's cool that I get a random number, but if I use that math.floor thing, it's going to round it. Basically what it's going to do, it's going to give us the largest integer it can that's less than or equal to this number. So the largest thing that's less than or equal to this is 0 every single time. So what I need to do is, instead of just doing math.random, I think what I want to do here, and let's actually write this just so we have this as a note. Math.random. We can then call math.floor on the response method to give us a whole number. So let's just do on the next line, which will be the largest integer less than or equal to a given number. Just so we have that for later. So what we want to do, I don't want just zeros. I want 0, 1, or 2. So if I multiply this by 3, save it. I guess there's a little bit of math going on here, but now that I multiply it by 3, you can see I'm starting to get different numbers. So now I'm getting 0s up front, 1s up front, and 2s up front, which is perfect. And I'll never get a 3. The best I can get is a 2.9999999 repeat. I'll never hit 3, which is exactly what we want. So that will put us in a great spot where now I could have, if I chop off everything after the decimal point, I could have a random reference to my array. And that's what that math.floor is going to do for me. So if I go to my math.floor and wrap it in parentheses like this, now I'm saying math.random, give me a random number from 0 to 0.999 repeating, multiply it by 3, and whatever that number is, chop off everything after the decimal point. And that's what math.floor is doing for me. So I'm going to save this and demonstrate it once again. Hit R and hit my reset, and now you're seeing I'm getting a whole bunch of whole numbers, right? 1, 2, 1, 2, 0, 1, 2. And these are perfect because they can be references for me in my array. So we can chain one more thing in front of this, and I can say, give me the letter at this index. So I can say computer options at index, whatever number comes back. So this would be, give me a random number, multiply it by 3, whatever number comes back, round that down to the closest whole integer number, and then whatever number that is, give me that index in the computer options array. There's a lot going on here, so it definitely might be worth doing some Googling and kind of playing around with this a little bit yourself. But just to demonstrate, if I save this and go back one more time, press R, now I'm getting random letters from my computer options array, which we can now map to the computer picking something, rock, paper, or scissors. So really cool stuff. Really interesting way where we can get a random letter without really getting a random letter, right? We're getting a random number and we're matching that up to a random letter. So pretty cool stuff there. So what I want to do is I don't want this to happen on the reset button. What I really want to have happen is I want this to happen every time I pick a guess. So what we'll do here is we'll say, we'll call this function right here. So we'll say computer picker, and I'll call this function. So every time I hit RPS, it'll log the key I hit. It will obviously update our display, and then it'll call computer picker, and computer picker will log it here. So let's just test that, make sure we're still working. So I'm going to press R, and I'm going to press R again, and you can see those logs are still happening. This is that log. Let me actually do this a little bit better. Let's just put the computer chose plus that. So they should say the computer chose and whatever they picked. So we'll refresh this again. The computer chose P. So I pressed the R key, the computer chose P. I pressed R, they chose P again. I picked R, now they chose R. I picked R, they picked P, R, P, R, R. There's finally an S. So it is a random option that it is choosing. The other cool thing that we can do is this computer picker function can actually return a value. So what I could do here is I could actually return computer choice. And when I do that, I can actually set a value up here. So I could say var computer, do we use computer guess yet? Let me check. See if we get an autocomplete computer guess. No. We'll say var computer guess is going to be equal to computer picker. So this variable computer guess will be equal to whatever this returns to me. And what is it going to return to me? It's going to return to me the computer choice, which is everything that we just set here. So I'm going to strip this console log out. And now I'm going to say the computer chose, and I'll use this variable that we get back. I'm going to save it, refresh it, and you're seeing same functionality, but now I have access to that value, the value that the computer picked back up here in this game start function. So the flow of this is pretty interesting. Every time I press a key, I call this game start function. Game start is going to see what key I pressed. If it's one of these keys, RPRS, it's going to log my key. It's going to update the display, and then it's going to call this function, computer picker, which is going to give me a random number, which I'll use in my array. It's going to return it back all the way up to here, and then I'm going to log that value out there. So pretty cool stuff where this code is going basically everywhere. And you know, we're able to use the power of these functions to kind of do some logic in another part of our application and bring it back to where we're eventually going to need it. So pretty cool stuff. And hopefully this will start connecting as we kind of wrap up this over the next 1 or 2 videos. The last thing I want to do, just for fun really, or not really for fun, but just to clean this up. I think every time we call, we hit the quit button, I think I want to call this initialize scores function again. So it won't do anything now, but if I quit and then I go back into the game, I think that should reset it. So it's kind of just like a little thing, but I think that's probably the correct behavior for how this should work. So we are now capturing our guess, which we've been doing. We're now making the computer pick its guess. So really the final part that we have to worry about is starting to calculate the scores and updating those scores on the screen. So that's what we'll begin doing in the next video, and I will see you there.